Engenhando Talks. Apresentação: Professor Fernando Lavoie.
Hi everyone, this is Engenhando Talks. We are here in University of São Paulo to talk about a very nice issue, sustainable cities. We have two guests here to talk about a little bit of this issue. So the first one is Professor Mroueh from University of Lille, France. Thank you, Professor Hussein, to come here.
Thank you for your welcoming. Thank you for this invitation. You're welcome.
Thank you. And the other professor from here, from University of São Paulo, São Carlos School of Engineering, Professor Cristina Tsuha. Thank you, Professor, for coming for the second time here.
Yes, thank you. It's a pleasure for me. Thank you for the invitation. It's also a pleasure to be here.
Thank you. Let's start it. So we will talk a little bit about sustainable cities. We have some important keys about this issue to have develop some keys in sustainable cities. So, Professor, what is the importance of the sustainable in urban development?
Thank you for this question, Professor Fernando. Maybe before directly answer to this question, I can introduce myself a little bit,
okay,
if it's possible. I'm, as you said, I'm a professor at the University of Lille in France, mainly working on geotechnical engineering and using some numerical models to try to better understand and also to design all the new technologies aiming to answer to the needs of our cities. And among these technologies, one is getting more and more importance. It's what we call energy geostructures. This technology is aiming, as you are saying right now, is aiming to answer to this sustainable city. So yes, it's quite a big challenge for us, for all the technologies that are developing in our universities to try to address this issue, because we know that nowadays one of the major issue regarding the sustainability of our cities is how to get some new technologies that are aiming to address this issue. How can from each of our discipline, how we can try to get some to give some insight in better addressing this problem. So maybe today it will be the good opportunity to talk about one of these technology, as I said previously, that are these energy geostructures. So I don't know how you want me to talk more about this, but we can then develop it in some coming questions.
Okay, yeah. Energy resources is a main key of the cities, especially the big cities. And we have in Brazil so many big cities. I think each capital of states in Brazil has a big city. It is a big city, right, Cristina? And in your point of view, how is the challenge about to manage with new resources in energy?
As Hussein also said before, we also in the same project about energy geostructures. What is it? It's using the geostructures existing as tunnels and diaphragm walls, foundations that are embedded in soil to change energy for cooling or heating buildings. In our case in Brazil, it's more for cooling buildings. In Europe, they use it more for heating, but we can use this for cooling buildings and also for heating water, because here you need water, hot water for shower, for cooking, and for other applications. Even in the industry, you have some process that you need to cooling and heating. For example, in silos, they need to dry the grains, they need the energy to dry the grains of silos. It's an example of application industry, but in some cases you need thermal energy. And the idea in sustainable city is to use from tunnels, walls, and the foundations for all became this kind of typical or usual in our big cities. It's very difficult. You need some rules, some policies to make this be a reality. But in Europe, they are more advanced, more in the Austria and Switzerland, maybe. UK, they are more. I think Hussein can talk more about Europe than me.
Yes, you are right. Maybe before talking about the technology, what we should understand, it's what is today the energy use in Europe, at least from European point of view. We know that for heating, cooling, and hot water, the energy use it's about 73% of the energy is used for this purpose, heating, cooling, so and hot water. So that means that trying to find some affordable, renewable technologies is one of the major challenge that our city today has to tackle with. That means that if we want to change the use and the customs of the end users on how we could reduce the use of fossil energy in order to get our cities and by our cities, our buildings more and more less and less, let's say, consuming fossil energies and trying to have some renewable energies to sustain to this use. That means that we have to look for some technologies. This is the first point. And when we talk about cities, we know that what is at the end, who is consuming? The need is coming mainly from the infrastructures, from the building. The building represent, with the materials, like 80% of the carbon footprint that is consumed in our cities. So that means that if we can offer some new technologies to reduce this carbon footprint, we know that it will have also a real impact on the sustainability of our cities. So we have several technologies that could be used. We can work from our point of view. We are, let's say, concerned about mechanical engineering. Even if it's a geotechnical engineering, it's mechanical point of view. But there is not only the technology who has to let's say, to get adaptation to this need, but also in the city we have the citizen. People also has to change their point of view. And at the end, what we should know is that in a city, you have how the people use their energy and what we can provide. And our work is to try to propose to the end users, to the citizen, some new opportunities. And we cannot do it by ourselves without adapting also the citizenship habits. So then, therefore, we have these two point of view that have to converge. Mm-hmm. So this is a very important issue to convince also the end users on the need to also change their use of the energy, not only us providing. And yes, as you were saying, Professor Cristina, we are trying to promote a new technology, which is this energy geostructure. So from where we started and where we want to go. This is not a new technology. When we talk about energy geostructures, we need to maybe to explain what is this energy geostructure. Energy geostructure, it's among one of the shallow geothermal technology that is quite easy to implement. We are now at a stage of knowledge where we know that this technology is quite mature. And people can go and look for this. We have today, internet is easy. Everyone can go and look on what is energy geostructure. And we know that this technology is very mature, but it is still not really well fostered. And our work is also to promote this technology. The promotion of this technology has to be done with the builders, the contractors, the people who decide, the councils and everyone, and at the end, the users, the citizen. So this is our main issue, is to propose some technology, to explain to the people that we are able to propose some new technologies, among them this shallow geothermal technology, which is quite easy to implement. How it works, we can explain it in details in some very easiest word. We don't need to give some very technical explanation on how it works. It's easy for us to explain it. But at the end, we have to convince people, builders mainly, to implement this. So this is mainly what we can do if we want to propose some new solution of having more sustainable cities. And why we also need it, because we know that we have also this need of adaptation to the climate changes. We know that we are all concerned in Europe, but also here, in quite all the world. We are concerned about this climate change issues, because we are getting some more and more drought seasons with very hot summers, with a high need of cooling, as you were saying, and some more and more rain and all these disasters that appears with this period of high raining, the flooding. So, and we have to adapt our infrastructures, because we have today some infrastructures that have been built at a certain moment of the timeline for a certain use, but the use has changed because people has changed, and the infrastructures are still the same. So we are now facing on the fact that our infrastructures are no more reliable to the need of today need of the cities, the need for the citizens, and also the need for the use of the infrastructure. So we are not only trying to promote a technology that is implemented for new construction, we are also trying to promote this technology because it can also be used for retrofitting. And this is also a very big challenge. And retrofitting of our existing infrastructures, it's really important. So in details, we know we are working on trying to understand how the technology we are promoting, our research, can give some positive results to these challenges. New construction, new buildings that have let's say a positive or a less carbon emission, a less carbon footprint, promote the fact that this technology can be also used for retrofitting, and by the same way adapting the infrastructure to the new needs, and also getting existing infrastructure, building mainly, or even others, that can also adapt to these climate changes and to deal with this sustainable cities. So this is in a large way how we would like to work all together. So my venue here in Brazil aim to this how do we say cathedrals?
Cathedra.
Yes, this cathedral. It's a very good opportunity to see how we in Europe work and how here in Brazil also things are getting. And we see that we have some very convergent point of view in many things in research, and we have to learn about how also you are developing this technology. What are the challenges for some other climate condition? Not only because in Europe we are, even if we have some disparities between South Europe to Northern, even if we have some changes, but here we have very two separate point of view, and it's also quite challenging to see how the technology we are trying to promote, this energy geostructure, can be at the same time can have a significant impact and positive impact here in Brazil, but also in Europe. So it's really a very good opportunity for me to come to see how research is doing here, what is done, and what we also do in Europe. And Professor Cristina will have the chance to come in France also to see what we are doing more in details. And yes, this is the fact. That,
very nice.
Yeah.
And Professor Cristina, in your point of view, what is the gap between Europe technology and Brazilian technology in this way that Professor Hussein told?
First, the needs are different. Né? For us, we need much more energy for cooling than for heating, because the climate in Europe is different, and I'm just thinking about it, São Paulo State, for example, but we're using much more air conditioning than we don't need it. Only heating swim pool or heating water, etc. But our need, we spend a lot of energy for cooling, and it's increasing. We can see that this last winter in Brazil was very hot. Yeah. For example, and we're using air conditioning even in winter here. And before was not like that. It's the problem of climate change. Né? And the gap is that we have nothing yet. Né? We have only testing. We have a kind of pilot building in São Paulo, a poly, 6 building. Is in face of the civil engineer Polytechnic school. We have constructed the foundation in energy piles. The piles for this building, we installed some pipes to exchange heat from the building with the soil. So the soil temperature is much smaller than the air, the air inside the building in the summer. So we can use a heat pump and have this heat exchange. Né? The idea is to use the cooler temperature of the soil to cooling the building side. So it's a simple idea. We can use the piles, we can use even tunnels, any kind of structure that is embedded in the soil, like contention walls, retention walls, or diaphragmal walls, any kind of structure that is in contact with the ground. We can put some pipes inside, circulate water, and use a heat pump to change. In the case of Europe, the inside the buildings are more cold than the soil, so they're doing normally the reverse.
Yes, the reverse part.
And this is I think using geostructures starting the 80s, about 1980 something.
Yes.
In Austria.
In Austria was
the first case.
The first cases. It's quite let's say old technology, mature. Let's say mature technology instead of old, because it started it started 40 years ago, but yet up to now it is not really widespread as we would like to be. This technology has a very promising efficiency, and it is not really used as we would like to be. So. Maybe we can talk about maybe if you want to follow your discussion about the gaps, or I can.
Yes, you can. Yeah, the gap is that in Europe, they started much before than us. I started just doing the first test in Brazil of an energy pile foundation. I did some piles here in São Carlos in 2014. More than 10 years ago. And after I have opportunity to using a kind of building in São Paulo campus of the USP, to implement the pipes into the foundation. So it's a real case that you can monitor. In this case, we also installed some sensors in all the foundations, and after the building be completed, constructed, we can monitor how much of electrical energy we can reduce in this building by using this technology. So you monitor that, you have some numbers, and it's a kind of real case that we can show for the people, oh, it works, and we reduce 30%, 40%. We have some calculations of electrical energy for air conditioning. This building is a living lab building. So it's just for testing new technologies. And they have some laboratories, some auditoriums. And after the use, you can give this answer, but it depends on the type of the soil, if you have water in the soil or not. The efficiency depends on many aspects, and one of important aspect is the ground properties, soil conditions, and we are geotechnical, me and Professor Hussein. So that's why we are in this topic, and we know this part of the problem that is the ground. In some places it will be more efficient, in other places it will be less efficient. But even less efficient could be, at least we can reduce part of the energy consumption, the fossil or electrical in our case, because in our case, the electrical energy, we don't use gas for heating like in Europe.
There is also another gap that maybe we can talk about. In Europe, we have some tools that help us to not only developing the technology, but also trying to create a kind of network to share our knowledge for fostering this technology.
Here you don't have.
That here you don't have. And we had this discussion last week when I was in the University of Sao Paulo, in Sao Paulo, in the city, and to try to create this kind of network here in South America, as we did in Europe, and in France. What is this network? We have a tool mainly which is called Cost Action. Cost Action is a tool promoted by the European Commission that is aiming to create a kind of network for people to all share their experience, their knowledge in order to promote the technology. And we have submitted a proposal 3 years ago for this topic of fostering energy geostructures, and aim to this proposal we get a success, and now we are working since 3 years on fostering our knowledge, and we are up to now, we have created a network of about 200 members coming from 36 European countries. So imagine the powerful of this tool, where we can all together discuss in some physical meetings in some different places 2-3 times per year, creating some events, training school, workshops with industry partners, and we have developed this networking. This tool is our tool is called Foliage, Fostering Large-Scale Implementation of Energy Geostructures. And this is really interesting because what we did as a first step is to try to draw a kind of map of where this technology is yet implemented, at which level of complexity, pilot case, real case, and so on, and aim to all the data we have collected. We had some like more than 800 collection data of implementation of this technology, and this is why I was saying previously earlier in this discussion that it's a mature technology, because we have this now feedback, this knowledge that this technology is quite mature in Europe. It's not only on some pilot cases as you are doing here.
This
It has been implemented in some real cases, in some real
This is the oldest
buildings,
of it.
airports, hospital, several buildings, and in also in using several geostructures, not only piles. Piles is the most convenient way to capture or to exchange heat with the soil, because quite every day you have some infrastructure, some buildings that are built with piles. So it's quite easy. But there are also some other technologies, diaphragm walls mainly when you are constructing a building, a metro station. So diaphragm walls and tunnels, as you said. In some retrofitting application, micropiles also. We have collected more than 800 case studies where we know that we have this knowledge about the quantity of energy that has been that could be exchanged with the ground, and how is the impact on the sustainability of the building, and also we have the quantity of CO2 saving aimed to this technology, and it has a real positive impact. So we have a technology that is a renewable one, free. We can get heating and cooling from the ground, quite with a very low cost. The extra cost of implementing it, it's quite small regarding the global cost of a building, for instance. So we have a very good performance of this system. We have some data. We have the quantity of CO2. We know how to calculate the quantity of CO2 saving. So we have a technology that has a very low carbon footprint. So this is really interesting. And we have several cases, as I told you, and we have this knowledge. But when I say 800, maybe it appears a huge number. But in reality, it's not so huge, because the potentiality of this technology is quite much more huge than it is already done. So our work, by doing this research, it's not only to look after the, let's say, technical issues, because there are still some unresolved technical issues we are trying to work. As I told you, we are also talking about this data collection, okay, so to know how it is widespread up to now in Europe, but also over the world. We have some case studies coming from North America, China, Australia, for sure in many countries in Europe. Now we know that at least there are some case studies here in Brazil that we can also integrate in our database. But there are also some other issues, maybe we will discuss about it later, about legal issues, non-technical issues, and so on. So maybe it will be the opportunity to discuss it later. So this cost action we are involved in is trying to, yes, get us having a more knowledge about what is already done in Europe, but also outside, abroad, and trying to foster the technology. So this is how we work. And this is a real gap between the tools we have in Europe that is facilitating us to exchange, and what is done here, which is quite, limited, but very impactful. What I saw here doing by Professor Cristina, I was really impressed by the quantity of research that has been done, because it's some, even if it's pilot cases, it's some real cases. And as Professor Cristina said, she has implemented some monitoring, some sensors inside the field where she is involved. And these are the most important to get the results of this installation, how it works, how many quantity of energy I can get. It's easy to calculate. If we know the temperature exchange, then we know how to calculate the energy provided. And we are also trying to show that this technology is quite confident. It's easy because if we put some strain gauge, some strain sensors to measure the deformation, we can also see that the deformation induced by this variation of temperature induced on the geostructure is quite small. So there is no, let's say, real technical issues. We still need today to work on how to better estimate the performance of this technology in some challenging condition, challenging ground condition, challenging environment condition. This is mainly our research topic because this is our technical background together. But there are some other issues, maybe we will discuss on it.
About the gap, I think here in Brazil, I'm almost alone. Doing that, we have some people that are doing numerical simulation in Brasília, UNB, some studies in Paraná that they start to investigate this kind of geostructures. But we in the University of São Paulo, we are the pioneer in Brazil to investigate the use of geostructures. In Europe, they are lucky because they have this kind of cost action. Is kind of project with different countries in Europe to focus on in how to divulgate this kind of technology. What I can do, what I did. I have participated in the first cost action, the second one.
Third one. The first one.
Yeah, in 2015, as a foreign
international partner.
International partner.
IPC, international partner country.
Yeah, we was international partner, so that's why I started to investigate this in Brazil. I was international partner just to look what they are doing and how they do, etc. And I don't have partners in South America, but I have partners in France and the UK, and also in Australia. I visited Professor Narciso, prepare a project, so to try to understand how they do there and how we can adapt this to Brazilian climate and the needs, because our demand is a little bit different than these other countries. So my research is how to adapt this for our condition. But unfortunately, we don't have kind of cost action, and the Europe is much more developed in this kind of technology than us. So we start from the zero. Now I think we have many data. We can understand a little bit about the heat exchange in saturated soil in São Paulo and unsaturated soil in São Carlos. That's a kind of different condition and also different efficiency.
Geotechnical conditions.
Geotechnical condition, but also heat exchanger condition and efficiency, because if you have more water in the soil, in the ground, you can improve you can get more energy in a simple way. So we can understand our kind of types of grounds in Brazil and condition, demand of energy for cooling, and we are trying to adaptating and using some pilot cases, and we go. But I think we are, as Professor Hussein said, we already have many results, so you can have some idea already. But I think a pilot case is very important to prove for the society that it works well, and we can reduce some.
That's the point. I will change a little bit, and I need to talk a little bit about the society, because clearly you are in the front of the science, or in the science frontier about this issue. But I think that society needs to work with you.
Yes, this is what I was saying.
How can we change this? Because we need to change the culture of the people, right?
Yes, exactly. This is exactly the second point of view of what we need to do, because from one side we are scientists, so we can promote a technology, we can work on all this technical issues and even non-technical issues regarding legal aspect and integration with other technologies and so on. There are many things that we can do. But on the other hand, what we have the end users, and we have also to not educate, but maybe to explain to our end users that if we are promoting a renewable technology that has a way to work depending on the ground condition and the season, they also need to change their use. Today, people, or maybe previously people were used to, I don't know, use the air conditioning maybe for all the day, maybe getting the light turned on
all day long.
All day long.
Without.
And these are some small changes. It's easy, but when we use a technology that is highly depending on the environment, the ground, the air also, or then this technology is not capable to produce to get all the energy at the same amount all the day. So people has to also to change their use of and start to know that, for instance, in their home, if there is a building that is connected to some renewable systems like energy geostructures, but maybe also combined with other renewable solution, people have to take care on how they can keep the window open, for instance, because with some climate condition, if you will let the window open, the heat will enter. Then you will need more cooling and so on. Maybe the way of using their energy has to be changed. The temperature of the water, for instance, can be reduced, and so we have to explain to the end users, because at the end the citizen is the main actor. We cannot do anything if the citizen at the end is not working with us, because everything we will do will be lost. So we need to. I'm not a specialist of humanities and understanding how people think. There are some disciplines in our universities. They know how to deal with, and we are working in our course actually with some people that are, let's say, much more concerned about these issues. I cannot talk too much about it. This is a point of view, and there is also another point of view. It's that the policies today are maybe not adapted to these technologies. So we have also some legal issues to deal with. If the contractor is aiming to use to implement this technology of energy geostructures, why he will do it if he has no incitation from the political government, from the government? How could we adapt the policies today to encourage contractors, builders, constructors to integrate this system? So they also need to be, let's say, to work, with a new framework. Maybe the tools that are quite existing today, maybe they are not really adapted to these changes. So there are some work that need to be done also from the legal issues, the society and from the society to adapt many things to the technology we want to promote. And how they can do it, they have several tools. It could be like, as you were mentioning, we can estimate the quantity of CO2 saving. It's an indicator. Yeah. And as you can say that this technology can reduce, maybe you will receive more fundings from some national agencies to promote, to have some funding to promote the technology. This is a first thing, and also what you need is to to explain to the contractors that by installing this technology, you will get, how can I say it, a more sustainable building for the, at the end. We talk about life cycle analysis. This is the work I was looking for. It has a real positive impact on the life cycle analysis of the building. So when you start talking about these aspects, then they start paying much more attention on what you are saying. Because if we only talk about energy, science, and so on, then you say, okay, but at the end, economical aspect.
Yeah.
What is the economical impact for us? So LCA, return of investment, and funding, getting funding to promote the technology, so legal issues, all these things need to be also adapted to this technology. So these are some issues that people also need to work. So this impact at the end, the people, the person who is in charge of giving the money, if he is convinced, he will do it.
Yeah.
If he has some incitation from the government, they will do it. But if we don't have it, we can't continue working as long as we want. And we have some very positive results. We know how it works. We can, but at the end, it will not be implemented, and
In the society.
and so we cannot really promote and implement this technology without the acceptance of the society. By society, I mean the end users, but also all the people that get the decision, that take the decision.
Yeah, for me, it's a hard point in our discussion, because to access the society sometimes is not easy for us.
Definitely.
Yeah, but you told that this kind of structures are low costs.
Yes.
Yeah. How does it cost in general?
I'm not an economist, but we can try to estimate it easily. In fact, if you want to estimate it, maybe we can talk about in details how it works. What is this technology? Because from the beginning we are talking about energy geostructure, but maybe we did not explain what is
also
this.
it's not a new structure. We use the structure
Yes.
that is existing. We also constructed foundations for the building, constructed tunnels for metro. For example, São Paulo City, you have a lot of tunnels. We constructed walls, rotation walls, not only for metro, but in São Paulo there are many buildings that you have subsoils, 4-3 garage, a bit underground.
Parking, yes, the parking.
Have parking with the big buildings. This is very common. In São Paulo have parking on the ground. So you,
2, 3,
so you have
4
contact
floors.
also the slab,
the basement. Yeah?
the basement of the garage. You have contact with the ground. So you can put only the cost is putting pipes. That is a PAD pipe. Is plastic. So is the cost of installing the pipes inside the piles, inside the walls, inside the tunnels. That is not, we can connect this to the cages. So as a civil engineer, the cost of this is not very high. I think it's a small percentage of the construction. It's very cheap.
Yes.
Maybe the heat pump could be more the system. It to be connected to the air conditioning system.
The most expensive part, and which still represent a very small. It's the ground heat pump, because mainly the system, these energy geostructures have to be have to be connected to a ground heat pump. Not in all cases. In some cases, we talk about geocooling. That means using this energy, this exchange of heat without ground heat pump. But in most cases, we have some heat pump. But yes, coming back to the technology, in all cases, you need to build when you need to build a building with some piles, or when you need to build some parking with some very high diaphragm walls in contact with the soils. In all cases, these structures have a first structural role. We are not doing some energy geostructures to exchange heating with the soil. Otherwise, we have some other conventional geothermal systems, boreholes, open loop system, many things. Here we are talking about first a geotechnical structure that has a structural role. And what we do is just to embed inside these structures. Often we have a steel cage, a steel reinforcement cage when we talk about with the concrete. You have this steel cage, and what we do is just to embed some tubes. Okay, maybe there are some hundreds of meters of tubes or kilometers of meters of tube, but at the end, the extra cost is some percent. It's insignificant. The impact it's elsewhere. It's not really on the cost of the material. Material has no. You have the installation of the material, the heat pump, and that's it. And what we try, in fact, what we try to promote today when we talk with some builders, it's to say, okay, guys, when you have a building that need to be funded with some piles, just put some tubes inside and forget them. Just put the tubes. Maybe you not connected to any ground heat pump system, nothing. Just put them, and maybe one day you will say, "Oh, I have a system. I have these pipes, and I can use them." Maybe in 5 years, 10 years later, but at least just put the extra cost. It's quite insignificant. There is a cost. In fact, let's say an indirect cost, but there is another cost. The cost comes from it's a human cost, because when you implement these tubes on the field, in fact, you have to change the way of working. The workers have to pay attention, because you have some tubes, and if they destroy it during the work, the system will not be work. So they have to pay attention. So sometimes, up to now, maybe the main challenge is during the installation to adapt the process of the work to this. And this is not so common, because they need to change also some, but everything can have a solution. Just that they just have to change the process to take it into account. So that means that, okay, maybe it will get, I don't know, 10% much more time to install at the end the piles than they do. So it has a cost for them. They will say, okay, look, time is money, and we need I don't know, 3 times much time to install all these tubes than we are used to do. But at the end, when you look on the global cost, there is a term, it's called capex. Capex, it's an economical word that estimate the effectiveness of the cost and also that integrate the return of investment and so on. It has a very positive. The return of investment is less than 6 to 7 years. So we know that it works very well. Okay, there is a cost. At the end, this human aspect I was talking, the technical aspect, the tubes, represent some percent, less than 5%, 10% maybe. But the efficiency and the positive aspect, looking at, as I said, the impact on the carbon footprint, CO2 saving, energy extracting or exchange with the ground, reducing the cost of heating and cooling and hot water from 30 to in some real cases 70% of the energy demand has definitely an impact. And all these small changes at the end has an impact on what we are talking about since the beginning, the sustainability of our cities. If each of these pieces are all put it together, at the end we will have a result. But if we say, okay, look, we just saved 30%, it's too much complicated. At the end, if no one change its use, we will never adapt to the climate changes and to the need of of global change that the
Also,
society
you are
is
using
asking.
the ground that is under your building, so you are not using the energy from other sources. You are using your own
that exists.
site. I have a site. I have a site to construct a building, so I have the underground is belong to the constructor, so he can use their own, and can use is yours. So it's something that is, you just use this. You have this below your building, but you don't know that you have this kind of capacity of use this. This is important. I have here below this room, not because you are on the second floor, but if you are in the first floor, you can have just below the slab. We have ground here that we can put some pipes, circulate water, and the water will come back colder than the temperature here. Because for example, in São Carlos, the ground temperature is around 23, 24 degrees all the year. Even I have 40 degrees outside, the soil is 23 degrees. So just to understand, is something that just using the thermal capacity and the thermal properties of the ground that you do. This is something that you are not using, that we have, but we are not using. So this also inside the idea about when you think about the costs and
exactly.
We are using only for foundation. I'm using the soil for foundation. I'm using the soil because I need to support this soil, support the load of the building. But I also can use the soil to heat change it. Change heat with the building, not only for supporting the building. I can have two applications for the same ground. The ground is good for us. I'm geotechnical, I'm foundation engineer. The ground is important because the ground will support the building, but they can also be used for other applications and reduce the costs of energy, electrical energy. For us, it's electrical energy, not use for, but it's something the people should say, how can I say, it's complicated to say, to see the advantages, because we know we have studied this.
There are so many benefits, it's clear. In your point, Professor, how are the trends of this kind of systems? We have to improve very fast, or you can see some problems to improve fast? Because you told about an important word that is climate change. It's our it is very important today.
Undoubtedly.
Yeah.
You're right. The trends, it's how fast. The fact is, we definitely need to follow to continue our research, because as I said, this technology is quite mature in some cases. For piles, what we call energy piles, it's quite mature technology. It has been implemented in some real cases for more than 10 years, 20 years, and we know how it works, everything we know. There are some, still now there are some limited cases because some conditions are, let's say, more challenging, and where the knowledge were not really able to address this issue, now we have some tools that we can use for let's say, answer this to these new challenges. So we have some new tools, some new ideas on how to continue to accelerate the promotion of this technology, how to foster. We are aiming now to work on, as I said, this challenging ground condition, where up to now this system is not really used, because in some cases the lack of knowledge let us maybe be quite not so confident. So this is a first point. We are also working on new use of this technology. It's not only heating or cooling, but it's also the storage as a storage system, because this system can be used to store the energy that is not used, that is produced in some. Let's take the example of a data center. That data center is producing too much heat. Most of this heat today, it's going out. And if connected with some specific geothermal heat pumps, we can use some energy geostructures to store the non-used energy produced in the ground for a future use. Or maybe integrating this on a network of district and heating cooling system and share a heating that is provided from a place to another use. So these are the challenges that we are trying to tackle with and to accelerate the acceptance of this technology. And these are mainly up to now the research that we are trying to develop today.
Oh, very nice.
Yeah.
To store.
Yes, storage purpose.
Oh.
And also use of some abandoned cavities in some cities. I don't know if it's the case in Brazil, but in Europe you have several cities where you have some cavities under the cities. Cavities that are coming sometimes from human activities, mining activities and so on. You have some cavities that are abandoned. These cavities have a potential of energy storage that is not really used. So this is also, talking about storage, this is also a very good opportunity to see how energy geostructures can be integrated in these systems to store the energy in these abandoned mines and or other abandoned other cavities, and how it could be beneficial for its efficiency to store at one moment at one time of the season for another season.
Very nice.
Yeah.
Very nice. So we are finishing our episode. I would like to thank you so much, Professor Hussein, for coming here.
It was really my pleasure. Thank you very much.
It was very important explanations about our present and our future, of course. And Professor Cristina, thank you again for coming here for the second time to participate with us.
Oh, it's a pleasure.
Thank
So-
you.
Thank you.
Muito
you.
obrigado.
Muito obrigado. So thank you so much. Bye-bye.